Hello, my name is Matthew Lee, and this time I will be talking about geometric sequences. Once again, before we move on, I will need to review some important vocabulary. A sequence is an ordered list of numbers, and a series is the sum of the terms of a sequence. Of course, in this video, we will focus on the geometric sequence. A geometric sequence is a sequence with the ratio between two consecutive terms constant. This is also known as the common ratio. This is an example of a geometric sequence. As shown, a common ratio of 2 is repeatedly multiplied on to progress from one term to the next. However, what if you needed to find a specific term in a geometric sequence? Well, you would use this formula. A sub n is equal to the actual value of the term you're looking for. A sub 1 is equal to the first term in the geometric sequence. R is the common ratio, and n is the desired term in the sequence. So how would we actually use this formula? Well, let's use it to try and find out the seventh term in the sequence 2, 6, 18, and 54. First, we would plug in all known variables into the formula. N is equal to 7 because that's the term we are looking for. A sub 1 is equal to 2 because it's the first term in the sequence. And R is equal to 3 because the common ratio is 3. Then we would solve like normal. 7 minus 1 is equal to 6. 3 to the 6th power is 729. And 2 times 729 is 1458. Which is the seventh term in the sequence. Moving on to geometric means. Geometric means are terms between any two terms of a geometric sequence. They can also be called the average of the two given terms. Now, in order to solve for these geometric means, we would use the formula mentioned earlier in the video. The most important thing to do when trying to solve for the missing terms is to find the common ratio. First, we plug in all the variables that we have available to us right now. A sub n is equal to 64 because it's the last term in the sequence. A sub 1 is equal to 4 because it's the first term in the sequence. And n is equal to 5 because we have 5 total terms in the sequence. Then we solve it to get the common ratio of 2. After that, we multiply each consecutive term by 2 to get the missing terms in the sequence, which would be 8, 16, and 32. So what if you were trying to find the sum of a finite geometric series? You would use the formula S of n is equal to a sub 1 times 1 minus r to the nth power, all divided by 1 minus r. S of n represents the sum of the geometric series. A sub 1 represents the first term in the geometric series, R represents the common ratio, and n represents the total amount of terms. Let's try using it in an example. Let's say you needed to find the sum of the first 8 terms in the sequence -5, 15, -45, 135, and so on. Once again, you would plug in all known variables. N is equal to 8 because it is asking for the first 8 terms in the sequence. A sub 1 is equal to -5 because it's the first term in the sequence. And R is equal to -3 because the common ratio is -3. Plugging in all the numbers, you should reach an answer of 8,200 for the sum of the first 8 terms in the sequence. I hope you enjoyed my video, and thanks again for watching.